In our next problem, we are given with a function f of xy is equal to fx into fy for every xy belonging to real. We are given with that if f is continuous at x equals 1, we need to prove that f is continuous at all non-zero x. Now in order to prove that f is continuous at all x which are not equal to 0, first of all let us find the value of f of 1, since we are given that the function is continuous at x equals 1. So putting x equals y equals 1, we get f of 1 is equal to f of 1 whole square. So f of 1 is either equal to 0 or equal to 1. So let us take case 1. F of 1 is equal to 0. Putting y equals 1 in this equation, we get f of x is equal to f of x into f of 1, and f of 1 is 0, so into 0. So our f of x comes out to be 0. Hence it is a constant function, and if it is continuous at definitely at x equals 1, it is definitely continuous at all x which are not equal to 0. Hence we go about with the second case. F of 1 equals 1. Let us take an arbitrary x equals a, and we will try to prove that the function is continuous at x equals a. Let us find the right hand limit at x equals a. We get limit h tending to 0 f of a plus h. This is equal to limit h tending to 0 f of a into 1 plus h upon a, taking a common. Now this is of the form x into y, and we know that f of x into y is equal to fx into fy. So this is equal to fa limit h tending to 0 fa into f of 1 plus h upon a. So this is equal to f of a, taking this f of a common, outside, since it does not contain any h, into limit of h tending to 0 f of 1 plus h upon a. Now this is the right hand limit of the function at x equals to 1, and we know that the function is continuous at x equals 1, and if a function is continuous at x equals a, then the right hand limit will be equal to the function's value, which is equal to 1. So limit h tending to 0 f of 1 plus h upon a is equal to 1, and hence we get right hand limit at x equals a is equal to f of a. Now we just need to prove that the left hand limit at x equals to a is also equal to f of a, because we know that for the continuity of a function at x equals to a, the right hand limit is equal to left hand limit is equal to the function's value at that point. So the left hand limit at x equals to a is equal to limit h tending to 0 f of a minus h. This is equal to limit h tending to 0 f of a into 1 minus h upon a, in the similar fashion as we did earlier. This is equal to limit h tending to 0 f of a into f of 1 minus h upon a from this relation. This is equal to f of a, taking f of a outside, since it is not containing any h, limit h tending to 0 f of 1 minus h upon a. Now very clearly this is the left hand limit of the function at x equals 1, and since the function is continuous at x equals 1, so its value is equal to f of 1, which is equal to 1. So this is f of a. Hence the left hand limit of the function at any arbit x is equal to f of a, which is equal to the function's limit, right hand limit at x equals a. So right hand limit is equal to left hand limit at x equals a is equal to the value of the function at x equals a. Hence the function is continuous at any x which is non-zero, which is our final result.